We're going to look at the distance between points, and our focus will be the distance between any 2 points on the coordinate plane. So if we have points A, x1, y1, and B, x2, y2, the distance between those 2 points is going to be giving us the square root of x2 minus x1 squared, or plus y2 minus y1 squared. Also, because you have a squared, you can also write it this way as the square root of x1 minus x2 squared plus y1 minus y2 squared for the distance. So we're going to apply that to a few problems just to show how this works. So find the distance between points A 5, 3 and points B 8, 3. So we're going to have our formula. R is square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 squared, so let's put that square root sign out here. x2 minus x1, I'm going to assume this is the point. I'm going to use B as the point with the x2 and the y2, and A as the point with the x1 and y1. So x2 minus x1 squared, so 8 minus 5 squared plus y2 minus y1 squared, 3 minus 3 squared. So we have a square root of 3 squared plus 0, which is the square root of 9, and that's going to give us 3. So R is going to be equal to 3 units of measurement. Another example. What is the distance between the point A42 and the point B16? So R is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to start with, I'm going to use B as the x2 and y2. So that's going to give us 1 minus 4 squared plus 6 minus 2 squared. So this is going to give us square root of negative 3 squared plus 4 squared. Now we're going to have negative 3 squared is 9, 4 squared is 16, which is square root of 9 plus 16 is 25, and the square root of 25 is 5. So the distance between those 2 points is 5 units. Another example. R is going to be square root of, you notice that I make it a habit of writing my formula first, or my equation first, so that it can guide me while I walk through all the problems. So now let's plug in the numbers. R is going to be square root of x2 minus x1 minus 5 minus 3 squared plus y2 minus y1. So it's going to give us, so minus 5 minus 3 squared. So this is going to be our x2, y2. This is our x1, y1. So you can switch them. And then y2 minus y1 is minus 4 minus 8 squared. Minus 5 minus 3 squared is minus 8 squared. Minus 4 minus 8 is going to give us positive 4 squared. So this is going to give us square root of 64 plus 16, which is the square root of 80. Now what we're going to do here, so r is the square root of 80 units. Now what we're going to do is we're going to write this in radical form and simplify this radical. So let's look at 80. Let's decompose 80. We divide by 2 and we get 40. Now we have 40, we decompose that, divide by 2, we get 20, and 20 decompose that, we divide by 2, we get 10, we decompose 10, we divide by 2, and we get 5. So we can see here, I'm going to group them in pairs. So we have 2 here, and so for this pair, I have 2 in that pair, I have 2 also here, so this is going to give me, and this is a single right here, so r is going to give me 4 square root of 5 units. If you need any help with this, there's a topic on radicals. Now finally, let's write the formula first. R is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in values. R, so x2 minus x1 minus, so square root of minus 6 minus minus 1 squared plus y2 9 minus minus 3 squared. So this is going to give us square root of minus 6 minus minus 1, that's going to give us minus 5 squared plus 9 minus minus 3, that's going to give us 12 squared. So this is square root of 25 plus 144, which is going to give us square root of 169. So r is 13 units. So these are the steps we follow to find the distance between 2 points on the same coordinate plane.